Good morning, afternoon, or evening, cats and dogs. We've got another lesson, lesson 1.3 on variables and expressions. Now, if you're thinking there's things Mrs. Garcia did not do from the lesson 1.2 guided notes, it's not a mistake. I do know that there are certain things that I want to make sure that we go through in class together. So there will be times when we might go a little out of order. We might skip some things and come back to it later. If I ever forget anything or miss anything, let me know. Keep in mind, I'm trying to keep track of a lot of different things right now, as are you. But we'll get through this together. We'll make sure you're prepared for tests, quizzes, and all that good stuff and independent practice. So you want to have your lesson 1.3 guided notes out and in front of you and looking at them because there's some things for you to copy down. Like our last video, this should be a relatively short one. Again, some are going to be really long, some are going to be a little shorter. It just depends on how much material we need to cover for the day. Just like last lesson, though, we start with some key vocabulary, including the word algebra. We're in pre-algebra, so we're kind of setting the foundation for the course of algebra, which it will take next year. And algebra is a branch of mathematics dealing with symbols and variables. So this tends to be one of those courses, algebra and pre-algebra, where this is your make or break year, where a lot of times if you've done well in math, you understood math, it becomes a little bit more abstract in pre-algebra and algebra with all these symbols and variables. And it can really throw people off at first. But again, I want you to bear with me. We can get through it. And algebra is something that's used in a lot of different careers. In fact, working at home with my husband over the last several months, I see a lot of algebra that he's working with in his career as an engineer and a planning manager. So, it is something that you may use in real life. Maybe not in your daily life, depending on what career you choose, but it could be. A variable. We see a lot of variables in pre-algebra and algebra. This is a letter or symbol that we use to represent an unknown value. We use these a lot. A lot of times we're solving for the variable. Now, in our last lesson, so earlier on in the virtual learning, you worked with numerical expressions where you were easily able to just calculate a solution using the order of operations. But for an algebraic expression, this contains at least one variable. So it's not as easy to solve. If we don't have it set equal to something, we can't necessarily solve for that variable. But we can represent different situations using expressions. So down below, and you're going to want to fill in these boxes here, these were just 3 examples of algebraic expressions. 5a, 5 times the variable a, that is an algebraic expression. 3x minus 2y is an algebraic expression. I threw in a different operation there. So we've got multiplication with subtraction. We can also have variables on the exponent. So 9b squared, that's an algebraic expression. Again, you're looking for a variable somewhere in that expression. Now, what you're going to be asked to do in this video is evaluate algebraic expressions. You're going to replace the variable or variables with known values and then use the order of operations. Now, we did this in the last video from the lesson 1.2 guided notes, so it's really nothing new here. So I'm going to go through these examples fairly quickly. Now, I believe you do have some other assignments for today as well. They may be listed as optional, but that doesn't mean you shouldn't still look through those or at least attempt those assignments to get some additional practice with this. So again, some days longer videos, more new information. Other days like today, shorter videos, nothing brand new here. So in these exercise problems, it says to evaluate each expression if x equals 10, y equals 5, and z equals 1, and don't forget to show your work. Step 1 is always to substitute those values in for the variables, and then use the order of operations to evaluate. One question I get from students a lot is, do we have to use the order of operations? Well, yeah, you always use the order of operations. You can't just pick and choose. So number 1, x plus y minus z is 10 plus 5 minus 1. Work from left to right. 10 plus 5 is 15. 15 minus 1 is 14. Number 2, x over y. We're going to write that as 10 over 5. Divide 10 and 5. Of course, that's going to get us 2 for our solution. All right, let's move ahead. Number 3, 2x plus 4z. I just copied those directions over again. So 2x is 2 times 10, plus 4 times z is 4 times 1. So 2 times 10 plus 4 times 1. Do multiplication. 2 times 10 is 20. 4 times 1 is 4. Add 20 and 4 together to get a solution of 24. In number 4, we have xy plus z. So it says, what operation do you put in between the two variables that are side by side? Well, it's just like when you have a number next to parentheses. You squish multiplication between those two variables. Don't just smush the two numbers together. Like sometimes when I see xy, students will write that as 105 because they're like, that's a 10 and a 5, so that's 105, right? Please don't do that. Multiply 10 and 5. So we've got 10 times 5 plus z, which is 1. 10 times 5 is 50. 50 plus 1 is 51. So again, very similar to what we saw before. A lot of math builds on itself. So things we saw before, we might cycle back and see that again, or we might make it a little bit more challenging at times. All right, number 5, we've got 6y over 10z. So that's 6 times 5 over 10 times 1. 6 times 5, of course, is 30. 10 times 1 is 10. And of course, 30 divided by 10 is 3. Number 6, we've got x, which is 10, in parentheses 2 plus z, which is 2 plus 1. So start off inside those parentheses. 2 plus 1 is 3. You can drop the parentheses and change that operation to multiplication. 10 times 3 gets us 30 for our solution. Now, I can't say easy all along, so we see a problem like number 7, a little bit more challenging here. We've got xy, which is 10 times 5, minus 2x, which is 2 times 10, plus 3x over 2, so that's 3 times 10 over 2. So first thing, substitute. You can see that I did that here. Now, let's do our multiplication. 10 times 5, of course, is 50. 2 times 10, of course, is 20. 3 times 10, of course, is 30. So we work left to right at this point. Once we simplify our fraction, 30 divided by 2 is going to get us 15. So divide here. Then we've got 50 minus 20, which is 30. Do 30 plus 15. And that, of course, is going to get you 45 for your solution. All right, we've got 3 more to take a look at in this video. So again, nice short video today. Don't forget though to make sure you're looking at today's lessons and see what other assignments you need to complete besides just watching this video and copying down these guided notes. So number 8, we've got 5x, which is 5 times 10, minus in parentheses z, which is 1, plus 4y, which is 4 times 5. Inside the parentheses, follow those order of operations. So do 4 times 5 first, which is 20. I also did 5 times 10 at the same time. That's okay to do if you want to combine a few steps. I didn't get rid of the parentheses yet, though, because I still have 1 plus 20 in there, which is 21. Take 50 minus 21, which is going to get us 29. Number 9, x squared minus yz is going to be 10 squared minus 5 times 1. 10 to the second power is 100. That's 10 times 10. I also did 5 times 1 in the same step. Again, it's okay to combine some steps. That's going to get us 5. And of course, 100 minus 5 is 95. Finally, number 10, we have 4y squared. That's going to be 4 times 5 squared. 5 to the second power is 25. And of course, 5 times 25 is going to get us 100. Again, this is really no different than what we saw at the end of the last video. So we've seen this topic before. What we're going to do from here in class is we're going to be building on this. We're going to write numerical expressions, but we're also going to write algebraic expressions. So we're going to practice working with both, not just given the expression, but we're going to write them ourselves. So be ready for that, and thanks for listening.